Welcome to FMSP Online Revision. This session is for OCR D1 and the topic we're going to be looking at is algorithms. So we'll start by having a look at the specifications for algorithms and then we'll work through a couple of exam questions just to try and help you get as many marks as possible when it comes to the exam. So 5 points to look at here. Candidates should be able to understand the definition of an algorithm, appreciate why an algorithmic approach to a problem solving is generally preferable to ad hoc methods, and understand the limitations of algorithmic methods. Understand the meaning of the order of an algorithm and determine the order of a given algorithm in simple cases, including algorithms for standard network problems. And part D, interpret and apply simple algorithms defined by flow diagrams or given as a listing in words. And last part, show familiarity with simple algorithms concerning sorting and packing, including the bubble and the shuttle sorts, and the first fit methods, that is first fit and first fit decreasing. So just notice these are the ones that you need to learn. Those are the only ones that you actually need to learn. Just looking at part D here, interpret and apply simple algorithms by flow diagrams. Just when you're doing those sort of questions, do put your results in a table. If you can do that, then it will be very much easier. But we'll have a look at a couple of questions now and hopefully draw out a number of these points. So the first one, and it is quite a long question, so there are 2 pages here, but basically we've got a set of numbers. We've got to do a bubble sort, where we've got to show the result of the first pass and the number of comparisons and swaps, and talk about which marks, if any, are guaranteed to be in their final position. We've got to write down the list at the end of the second pass, and how many passes are needed to get the 95 to the start of the list. So they're wanting to go in decreasing order, so we need to get the largest to the top. Then in part 2 we're going to use a shuttle sort. So we've got to show the results of the first and the second pass through with a shuttle sort, recording comparisons and swaps. Explain why for this particular list the total number of comparisons will be greater with the bubble than with a shuttle. And then the last little bit here is we've got the information given to us that a shuttle sort is a quadratic order algorithm, and we've got to try and work out how long it's going to take to sort a list of 50 marks if we're told it takes 20 seconds to sort a list of 10. So quite a long question to read through. So let's have a little start at the first bit, which concerns the bubble sort. So we're asked to do a bubble sort. I've listed the numbers here again for us. These are the numbers that we were given. So notice that you have got 10 numbers. So as long as we know we've got 10 numbers, for a bubble sort in the first pass we're going to have 9 comparisons. So remember, we're trying to put them into increasing order. So we will compare the 31 and the 28. Now 31 is bigger, so we don't need to swap. We're then going to compare the 28 and the 75 and swap. Then the 28 with the 87 and swap. And the 28 with the 42 and swap. And with the 43 and swap. And with the 70 and the 56, the 61 and the 95. So we're going to swap. Because 28 is smaller than all of those, we are going to swap all of those. So notice the 31 stayed where it was, but now the 75 will be next, and then the 87, and then the 42, the 43, the 70, the 56, the 61, the 95, and the 28 now will have gone to the end. So we have started with 10 numbers, so we had 9 comparisons, and we then swapped the 28 with 8 of them. We didn't swap it with the 31, so we have 8 swaps. So that's the result of the first pass. It says which of marks, if any, are guaranteed to be in their correct position. So mark of 28 is in the final position. So remember, with the bubble swap sort, that's what happens. So we now have completed that, done everything we needed there. So let's have a look at part B. Part B says write down the list at the end of the second pass. Now in the second pass we're going to now be comparing 9 numbers, because the 28 now is in its final position. So we will compare the 75 and the 31 and we'll swap them. And then we'll compare the 31 and the 87, and the 42 and the 43 and the 70 and the 56 and the 61 and the 95, and it is actually smaller than all of those, so we're moving everything up again. And we'll just write all those numbers down, and now we have the 31 and the 28, and we now have 2 numbers in their final position. So that is the result of the second pass. And then in part C we're asked how many more passes are needed to get the value of 95 to the start of the list. And remember, if we had 10 numbers we needed 9 passes, and we already have done 2, so we now have 7 more passes. So in terms of marks, while we're there, we got 4 marks for part A. So you got a method and an accuracy mark for getting your first pass. So as long as you showed a correct method, if you made a silly mistake you might get 1 method mark, but a correct first pass was a 2nd mark. You then got a mark for writing down 9 comparisons and 8 swaps, and a mark for saying that 28 was in its final position. And then for part B and part C, just 1 mark each for those statements. So part 2 now, we're asked about the shuttle sort. So let's have a little look at how we might do the shuttle sort. So remember, in the shuttle sort, for the first pass you're going to compare the first and second numbers and swap if necessary. And then when you've written down that result, for the second pass you're going to compare the second and the third numbers. So let's just see. So the first pass, so you're going to compare the first and the second, and there is no need to swap them. So if we write all of those numbers down, and really we probably should, although it just takes a little bit of a time to do that, then notice we've had 1 comparison but no swaps. And then when we come to the second pass, we're going to compare the second and the third number. Now of course 75 is bigger, so we're going to swap it. And then we compare the 75 and the 31, and we'll swap it. So the 75 is going to come in to the top, and then we'll have 31 and 28, and then all of these numbers will remain the same. So as long as you realise we've compared the 75 and the 28 and swapped them, and then we compare the 75 and the 31 and swap them. So we have done 2 comparisons and we've done 2 swaps. And again you get a method mark and an accuracy mark for your first and second pass, and then you got a statement mark here for each of these results. So 4 marks for that shuttle sort. When we come to explaining why for this particular list the total numbers will be greater using the bubble sort than the shuttle sort, then it's worth just noting that for the bubble sort, because it required 9 passes, remember we had 10 numbers, 9 passes to get the 95 at the start. So remember, 95 was right at the end. So in terms of comparisons, that means 9 passes, so 9 in the first, and then we will have, that's a plus sign, 8 in the second, and then 7, and so on, all the way down. So we will have the maximum number of passes needed. But if we look at the shuttle sort, and we'll have a little look back at the last slide where we had some of the shuttle sort, then in that shuttle sort, if I were to look at a third pass, for a third pass I would look at the third and the fourth numbers, so I'd compare the 87 and the 28, and I would swap them. So I would end up having the 87 would then come to the front, so I'd have an 87 and then a 75, and then I'd have the 31, and then I'd have the 28. Now the next number was a 42. So I would then compare the 42 and the 28, but of course I would compare it then with the 31, but that is where I would stop. So I wouldn't have to do quite the same number of comparisons. So I would compare the 42 and the 28 with those two and swap them, compare the 42 and the 31 and swap them. I would compare the 42 and the 75, but I wouldn't swap them, so I've never had to compare it with the 87. So it's quite hard to write that down, but in the fourth pass, and that would have been the fourth pass that I've done, there is no need to compare the 42 with the 87. So there are occasions when you don't need to do every comparison. So the shuttle sort is shorter. If you've left comparisons to do, then it will be shorter. So as I say, not easy to write that down, but there is 1 mark for each of those parts. So 1 mark for mentioning about the fact that the bubble sort required the maximum number of passes, 9 plus 8 plus 7 and so on, and then there's a mark for trying to explain that in some cases the shuttle sort will not require every comparison. So bubbles and shuttles. The last bit of that question says, if the shuttle sort we're given is quadratic order and it takes Harry 20 seconds to sort a list of 10 numbers, then approximately how long will it take for Harry to sort 50 numbers? So if we look at that particular one, then what we're going to be looking at is we're saying that t, the time, is proportional to n squared for quadratic order. Now you could use that as introduce a constant k and work it out that way, but I'm going to do it just in the form of a table, and I think this is often just an easier way of looking at it. So if I have my time and my numbers, then if I know it takes 20 seconds to sort a list of 10 marks, I now want a list of 50 marks sorted, so I have multiplied the number by 5. But because we have a quadratic order here, what I'm going to do here is I'm going to multiply that by 5 squared. Squared being for the quadratic. And 5 squared is 25, and 25 times 20 is 500. So the answer is 500 seconds. So as I say, you may do that in a slightly different method, but I'll give you that method as a sort of, you might just find that easier. And there was a method mark for getting, attempting one of the methods correctly, and an accuracy mark if you got an answer of 500 seconds. So that is the first question completed. We're now going to have a look at a part of a question which involves the first fit and first fit decreasing. Often questions which are quite straightforward, but there are 6 marks for this, and you just want to make sure that you do everything quite carefully and you don't miss anything out and give away easy marks. So we've got to use the first fit method to cut the pieces. You've got planks which are 20 feet long, and we're cutting lengths of wood from it, and we're asked to use the first fit method to find a way to cut the pieces. So if we look at this, and it is part 3 of a question, so I'll just put that there. We haven't seen the first 2 parts. So we would have a cut of 3, then a cut of 10. Now we can't cut the next piece from that 20-foot bit of wood, so we'll need to take another bit, and we'll take a cut of 8 there. Then we have a 2. We could do that from the first plank, and that's important that we go to the first space available. Then a cut of 6, so we've now got 15 here and 14 in the next, and we have a cut. We need a plank of 11, so we're going to need a third plank. Okay, so again, sometimes it's a good idea, depending on the question, just to sort of make a note of how much we're actually using, and then we can see how much we're wasting, which is also sometimes important. So in part 4 it says use the first fit decreasing. So if we're put them in decreasing order, so it's going to be 10, 8, or even 11, 10, 8, 6, 3 and 2. So doing that, we're going to have 11 for the first cut, then we have a 10, so that's going to need a new plank, then we have a cut of 8, so that can go in with the first one. So we've now used 19, so we've only got 1 left. We now have a cut of 6 which we could do there, and a cut of 3 that we could also do there. And that is meaning that we've used 19 feet. But unfortunately that means that we've got 2 left over here. And it says, give a reason why this might be more useful than part 3. So notice that in either case we're using 3 planks. But of course here we've got a lot of wood left over, and there's very little wastage here. So there's not much wastage. In the first 2 pieces, planks, and there's actually 18 feet in the third, and that of course might be useful. so it's a decent length, isn't it? So it might be useful for someone else. Whereas in these we had wastages of 5 and 6 and 9. So I think it's some sort of comment like that that you want. So you got a method and an accuracy mark for part 3 for the first bit. So a method if you were starting it off correctly, and an accuracy mark if it was fully correct. And then in part 2 you got 1 mark for first bit decreasing and 1 mark for making a comment about the fact that this might be a better method. And then the last part of the question, find a more efficient way of cutting the pieces. So I think you've probably all worked out that it would actually be better if we used the 9, the 10, the 8 and the 2 and the 11 and the 6 and the 3, so that we only had 2 planks. So that's obviously going to be better. And in that case it says how many planks will they need, how many cuts will they need to make. So 4 cuts. So 2 pieces of wood, 2 lengths of wood and 4 cuts. And this is really just the first fit and the first fit decreasing algorithms are just an example of showing you that they're not always going to give you the definitively best answer. And that was one of the things that it mentioned in the specifications, that you do need to understand that sometimes, and this is a good example, that actually you can get a better example just by working it out yourself. So as I say, just 1 mark there for showing the 2 cuts and 1 mark for saying that it was 2 lengths of wood and 4 cuts. So I'm going to finish the video and the session here and just remind you that it is very important that you do as many of these questions as possible. That's always going to be the best way to revise.